Welcome to Conics 4, fourth day of working through conics. So what we're going to start with is mixed practice. And that, by mix, I mean it's a mix of all the conic shapes or all the conic sections that we've dealt with. So there's four types: parabolas, circles, ellipses, and hyperbolas. Yeah, that shouldn't be anything new. Let's go through the parabola and see what makes a parabola a parabola. So for example, if you remember, a parabola is either just a curve that looks up like this, or a curve that, there's four cases: this one, this one, this one, or this one. Yeah, we've covered those before. How do you know which one's which? By looking at the equation. Well, let's look at this equation. This would be, for example, y squared form. And we look at the p as well, so the constant. You should remember that if it's in y squared form, it opens left and right. So it either opens to the right or it opens to the left. So when it's in y squared form, if p is positive, it opens to the right. And if it's in y squared form, if p is negative, it opens to the left. That's a review of what we did at the very beginning of this unit. Okay, that's the simplest thing. And then if it's x squared form, we still look at p. Remember, this is called, I'll call this y squared form. It opens left and right. Second one, x squared form, opens up and down. And so we'll cover that a little bit more after. But again, this is just review. If you're given a circle, can someone tell me, like, really the one thing that is different about the circle than the other types? I can see that it has two squares here. What's the difference? All the rest have two squares. What's the main difference? The main difference is that it has a radius. So there's a number equal to a number, some number squared, instead of a 1. Okay? So I'll talk a lot about the differences in these things here. But really what you're looking for is squared and squared, x squared and y squared, and it equals to something that is not 1. Okay, that would be your circle. And of course you know what a circle looks like. If you have an ellipse, how do you know by looking at the formula that it's an ellipse? Well, it's pretty straightforward. You have squared, so you have x squared and y squared stuff, and you have this plus. So notice it's the same, x squared and y squared stuff with a plus. I might erase some of this highlighting after because I don't know how helpful it is, but I'm trying to write it there to help you out. Okay, so basically one way that I like to think about ellipses, you have something on top, an x-type term and a y-type term. And then the way I think about this, it's always equal to 1. You have something on bottom, I'll just make it a square, and something on bottom that's different is your triangle. Okay, I'm using square and triangle because sometimes it's A, sometimes it's B. That's not my point. My point is when you look at the equation, how do you know that it's an ellipse? Well, you know because you have x and y squared stuff with a plus in the middle, and the fractions on bottom are different. Okay, that would be your sort of key. Sorry, I need to fix my brightness. Okay, and let's look at the differences for the hyperbola. For the hyperbola, we still have x squared stuff, we still have y squared stuff on both of these. But what's the main difference? It's this minus. Yep, Kevin got it. Good job. It's the minus. So you still have x and y squared things. Of course, you can shift the center. You're going to have different things on bottom depending on what you have. Actually, for hyperbolas, it could be, it's A first always. But no matter what it is, who cares? It's the minus that matters. Okay, it's the minus. Now I'm just giving you general ideas how to pick these out so that you will be better at it later. So let me summarize. Parabola. One thing is squared, x or y. The other one is not squared. It's linear. Circles, x and y are squared, but they equal some constant on the other side. Ellipses, x and y are squared with a plus in the middle. And they have fractions. Hyperbolas are still basically the same as the ellipse, but remember it kind of gets inverted. It kind of explodes. It's like the circle came in on itself and then exploded out the other sides. There's a minus in the middle. Okay. So again, I don't know if that highlighting helps. If it doesn't help, just kind of ignore it. Okay, but this is just a reference anyways. So let's try some practice problems. Tom went through these if you watch the video, but because these questions are so important, I'm going to go through them again, especially because we have a little bit of extra time today, judging on how difficult this is, which is not very difficult. And we have time. I want to make sure that it's very clear in your head how to do this, right? So what we need to do, describe the curve represented by each equation. Identify the type of curve and its center or its vertex. Okay, so we have different curves here. We know they're curves because they match the equations that we expect. We just need to figure out what's what. So when I look at this, all right, or when you look at this, you need to be able to say, is this a parabola, a circle, an ellipse, or a hyperbola? Okay, it could be a really easy, nice multiple choice to ask you that. Looking at this directly, what is it? Anyone have any ideas? First of all, this is a y squared thing, and this is not x squared, that's actually just x. So if we're looking at y squared only, we have a y term that's squared and an x that's not squared. That would be a y squared form parabola. And because this 4 is positive, it would be called a positive p-value. It would open to the right. So this might seem like a million years ago that you learned that. It feels a million years to me because not only have I been teaching this 4 hours a day or 3 hours a day, I've been doing all the preparation for the assignment and the test and the blah, 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 blah. It feels like I've been doing this my entire life now in a bad way. It won't go away. But yeah, we did this Sunday. I just jotted down on the side what you could know at this point, but let's go ahead and answer the actual question. What's the type of curve? Right away, it's a parabola. You need to be able to tell that from the situation here. What else do we know? Do you know what the center is? Well, a parabola doesn't have a center, but a parabola has a vertex. And where's the vertex? Well, we look at the h and k. We have k here and h here. So this is kind of what we did previously, right? What we've been doing the entire time. That's our vertex. Remember, parabolas don't have centers, they have vertices. And it says to describe the curve. I'm just going to simply describe it and say it opens to the right. It looks like this. Excellent, Hansa. Maybe you have access to the other notes that I made. Maybe that's the secret. Maybe you have my other class's notes. So you watch the videos and that's how you know all the answers. Maybe. I'm on to you. I'm on to you. Maybe not. We'll see. Okay. And remember, this term in front of, tell us your secret. Who knows? I mean, the YouTube videos of my classes are online, so if you want a little sneak peek, you can always go in there. It's okay, so I'm only joking, Hansa. So this is 4p. Let's not forget that. And if we needed it, we would say 4p equals 4. We'll review that later if we need to. Let's move on to the next question, because we've already done all 3 pieces for this. For b, so tell me, what kind of shape is this? What kind of conic section? Is it a parabola? Clearly not, because you've got 2 squared values. What does it look like? What's it going to be? Anyone have any ideas? I know it. It is ellipse. It is ellipse. And the reason it's ellipse, just in case you don't know, even though you said it, is it's got the form of an ellipse. It's got this x squared part here. It's got this y squared part here. It has something on bottom, and this would be just over 1. This is what we would call the major axis. So this is a squared. If we needed it, we would write this down. In this case, we don't need it, but I'm just writing it to remind you what we've once done. And if you want to be entirely sure, you have an x squared over an a squared form, y squared over some b squared equals 1. That is an ellipse. And the main reason, really, is because you have this plus and you have these squares. Okay? So it's an ellipse. If it was a minus in the middle, if you just changed the minus in the middle, you would get a hyperbola. And this is not a hyperbola. Okay, so we need our three things. We have ellipse. What's the second thing we need? Does an ellipse have a vertex? It does, but it's only asking for the center. So the center. What's the center in this case? Well, you look at the x part, that's change that sign, -4. Look at the y part, change that sign, that's a +1. Samesies. I don't know why I said that. Just came to mind. Okay, and how do we describe this ellipse? If we were to say what it looks like, well, if I was to make a sketch, it would look like this. How do I know that it looks like that? Because the major axis is the bigger one. So A is the bigger one. It's related to the x, so it's stretched in the x direction. If you haven't been practicing this, and you haven't, if you haven't come to the classes and paid attention, if you haven't done the practice, if you haven't done extra practice over and on top of what I've given you, it's going to be almost impossible for you to figure this stuff out. So I hope that you've been giving it a shot. This, I'll just say that it's stretched in the x direction. But really, if you were to just give me that shape, I would be okay with that as well. So I guess everything this is all that I'm asking for is this. Everything else that I'm writing on the page, besides the three things, are just extra things to help you remember. But you don't need to write that yourself. Okay? You would just need to write what I'm writing here. Feeling okay so far? Yeah, so Hamza, you said it's horizontal. Same idea. You can say it's major axis is in the horizontal direction and the x direction. Some way of telling me what it would look like, describing the shape to me. Just need to move this. Okay. I'm going to say that that's okay because no one's replying to me, and that's okay too. In this case, I can see that we have squareds on the x and y's, but I have this minus in the middle. Right away, that's all I need to confirm that it's a hyperbola. And I know even more than that. I can make a little sketch. I know that the x squared came first, so I'll say x squared first form, which looks like an x. So we already know that. And if we needed a and b, well, I can take a and I can take b if I needed it. In this question, it's not being asked for. So hyperbola, does a hyperbola have a center or does it have a vertex? Well, it says right at the start of the question that I have to get the center for the hyperbola. So let's get that. Center. Where's the center? It's at 1 and 2, h and k. And let's see, how do I describe that? I can say opens left and right. I can say it's x first type. Whichever way makes sense to you, okay? You should just draw the sketch. That would be the clearest way. You could say opens left and right. Whatever, again, whatever makes the most sense to you to write it down. But you have to write something that's so clear or clear enough that when I read it, I know what you're saying. You can't just say opens or goes off in 2 directions or whatever. Use the simplest language you can while still telling me what we're talking about. You need to describe the shape. So if you draw a sketch, that's the easiest way. That would be enough. Okay. You wouldn't draw this because that would be the y first type. All right. So again, I'm going to keep on keeping on until anyone tells me otherwise. That's a quick and easy one. This next one, what is it? Hey, Abdo. What shape is it? Circle, and it's a circle because I've got these squared terms here and I have it equal to a constant that is not 1. Okay, so right away I can actually just write down that it's a circle. If you want to be super clear, it has this form. I mean, ignoring if the center was off center, it doesn't change anything. This is the form that we have. The r squared is what changes it. What do we need? Clearly the circle has a center. The center in this case is -4 and 2. And then I need to describe it somehow. I'm going to use the radius because there's no other way to describe a circle, right? It's not stretched any more in one direction than the other. It just has a radius. In this case, what's the radius? 5, exactly. So the radius r squared is 25. That means the radius must be 5. So if you were to draw a sketch of that, you know, I can sort of cheat because it lets me cheat. But this is what we're going for, okay? That's all the 3 things it's asked for. Remember, it said describe the curve, identify the type of curve, and give me the center. So I've described it by saying it's a circle, or I've identified it by saying it's a circle. I gave the center, and then the radius of the circle is all you need, really, to describe that. So I want to just show you something. I'll come back to that. I just want to show you this question that we were just given was this. And some students say that it's an ellipse. And you're not entirely wrong if you say that, but you're not entirely right either. Let's just look at this 25. Let's divide everything by 25. So if I divide everything by 25, what I end up with is this. This is something I haven't talked about because I didn't want to confuse anybody, but this is a good time to bring it up. Okay, so these are the same. The first step and the second step, they're the same. What do you notice? Now that I've divided everything by 25, it's now all equal to 1, and I've got this fraction shape. It has the form of an ellipse. That's definitely the form of an ellipse. With the squared terms, with the plus in the center, that's an ellipse. The difference is these are the same. You know, these are equal to each other. And for an ellipse, we need to have a major axis, a longer axis, and a minor axis, which is a smaller one. But this would mean that A is equal to A, or A is equal to B, I should say. So there's no stretch. So there's no point in calling it an ellipse because it's a circle. It's like calling a rectangle a square. Well, a square is a special case of a rectangle. A circle is a special case of an ellipse. I don't know if I confused any of you there. I didn't mean to. I meant to clarify. But in short, circles are ellipses, but they're a special case of the ellipse. So you should call them circles. That's the big idea that I'm trying to get across here. Who knows? It could be a bonus question. I don't know. I don't know if I'll give a bonus, but you never know. Okay, so the next section that I got to go into is slightly different. Same, but different. Is there anything I can review here? You know, this is the whole thing we just did. You're pretty quiet today, but feel free to say hi. Going once, going twice. All good. Okay. So the next section, honestly, is not very difficult. What we're going to be spending a lot of time trying to force what's called a general equation into our standard form. So we're going to be given equations that look like this, or something like that. This is basically our general form. And we're going to be forcing it into our standard form, like our form for a parabola, circle, ellipse, and a hyperbola. I'm trying to get it into these formulas, okay? And I don't like the way that highlighting looks. I might remove it later. Okay, so why is it called the general? Well, it's called the general because it's just this equation here can describe all of the conic sections. It means that if you remove some pieces, you know, set a few things equal to 0, set a few things equal to each other, it will give you any of the conic sections you want. Now that's not super helpful, but that's why it's called what it is. Second degree, do you know why it's called second degree? It's called second degree because we have squares. It means squares, these squares here are our highest power. That's our highest power we can see. That's what it means by second degree. And of course, equation just means it's equal to something. But in short, it's it's how we could describe any conic section. It can all have this form. I'm sort of going to skip this part because I don't find it very helpful. I'm going to talk about what makes our four different things, our four different conic sections. But I'm not going to talk about these rules because they're very difficult to remember. I want to give you an easier way, okay? So let's just say I want a parabola. I'm just going to mark this up a little bit. Let's look at this equation. Start with a parabola. How do you know that something's a parabola? You will have an x squared term or a y squared term, but not both. So you'll either have an x squared or a y squared, but you won't have both at the same time. Okay, that's how you know that it's a parabola. So let me I don't know, I guess I could write this down. Parabola, x or y squared. Okay? I should probably just say you have x squared or y squared, but not both. How do you know that it's a circle? You know it's a circle when you have, in this case, x squared and y squared, and the same number in front of both. Same number in front of both. So you'd have like 5x squared and 5y squared, or 10x squared and 10y squared, something like that. Okay, should probably fix that. How do you know that it's an ellipse? Well, you would have x squared and y squared. They would both be positive. You would have different numbers in front. Different numbers in front. So you'd have like a 3x squared and a 5y squared or something like that. And then how do you know if it's a hyperbola? This one's actually the easiest in my opinion. You have x squared and y squared. One of them is negative. So I can refer back to this after if you want, but you sort of get used to them after a while. If you just see one single x squared or y squared, not two of them, it's a parabola. If you see x and y squared and they have the same number in front of them, it's a circle. If you see an x squared and a y squared and they have different numbers in front of them, it's an ellipse. And if you see an x and a y squared, but one of them is negative, it's a hyperbola. Okay? So we'll see what I mean or why I'm talking about this in a second. But there's one more piece I need to give you of this puzzle. To complete the next problems, we have to complete the square. You've done this before. It involves creating perfect square trinomials. What it means is we're taking things that are in this form and making them look like this. Or more specifically, we're taking things that only have two terms and making it into a perfect square. Let me show you what I mean. I'm just going to go to the side here. Let's just say you had x plus 2 all squared. Okay, x plus 2 all squared. What is that really? Well, that's actually x plus 2 and x plus 2. And if we were to expand that, multiply everything by everything else, you end up with x squared plus 4x. Sorry, I'm going to fix this. I'm going to make it a 3, and just because I want to make a better example. 3. And then what do we get? We get 6x plus 9. Yeah? Are you with me so far? This is what happens when we expand this binomial. We just expand this, get back this, okay? Hopefully you're with me so far. In order to go backwards is actually pretty simple. We would take this and we would just say, what two numbers multiply to make 9 and add to make 6? And we would be able to factor that. So just keep that in mind for a second. The other question is, look, what if I had something like this? This will become clear as I work through it. What if I had this equation? What would I do in this case? How would I solve easily for x? Well, I'm going to show you how to do it by using complete the square. So just listen, relax, and I'll give you the steps. What you need to do is you need to force this into something that can be factored into something like this. And so the steps that you follow are just this. You take the x squared plus 6x. I'm not going to move the 5. Oh, okay, I'm going to mention that. Actually, it's a really good point. I'll talk about it now. Let's just say we wanted to move the 5 over and we ended up getting this equals 0. This is difficult to factor. What two numbers multiply to make 5 but add to make positive 6? We would have to use the quadratic formula. So we don't want to do that, and completing the square lets us ignore that. So let me show you. The trick is, and it is kind of a trick, I'm not going to explain it too much. Take this number, divide it by 2, and square it. So divide it by 2 and square it, okay? Take it, divide it by 2 and square it. What do you get? You get 3 squared. What's 3 squared? 9. All right? On this side, we have a 5, but we're actually not allowed to just add a 9. We can't just change the whole equation and add a 9. So I also need to add the 9 to this side. So let me finish up what I'm talking about here. Now I can factor this really nicely. This is, what two numbers multiply to make 9 and add to make 6? 3. The right side I'm going to just simplify. It's 14 now. And then I can see this is the same thing, so it's squared. I'm going to give you a shortcut, don't worry, I'm just trying to review this. Okay, and this would be a new form. You might think, how is that easier? Well, for these problems, we need to do it. That's basically what I'm going to tell you now. It's going to help us a lot in the problems that we're going to find very soon. So let me show you. We can basically jump directly from here to here. Just trust me, okay? Let me show you one more example of this in action, and then we'll jump into the real stuff. So let's say we have, let's just have a new problem here. X squared plus 4x equals 7. Okay? I just pulled these out of my head. It doesn't matter what the numbers are. How do we complete the square on the left one? Maybe let's see if we can remember. You take this number, divide it by 2. Let's make it a minus just to change it up a bit. Divide it by 2 and square it. What do you get? Well, if you divide -4 by 2 and square it, you get -2 squared, which is 4. So you get back another 4, but for a different reason. On the other side, we need to add the 4. And now we're almost done. We just take this and divide that number by 2 is the trick. Divide it by 2, put a square on the outside, simplify the right side. This divided by 2 gives this. They're related. It's always that divided by 2. You'll see. Just trust me. We'll see how this works out. And we would be done here. So before I do any more of these just examples with no context, let me give you an example from the notes so you can see how it works. And you can, go back to the video and see this. Take a picture if you want the example, but it'll be clear by the end of this lesson. I promise you that. There's some steps here you can use for reference. I'm not going to talk through them right now. But if you want to use this as part of your reference sheet for yourself, go ahead. Let's do these examples. Okay. This question wasn't done by Tom, so it's a good one to do, but I'm pretty much going to do most of the examples here today. Okay. First things first. We need to write this in standard form. And this is why we need the steps that are on the previous page. Once we get it in standard form, we're going to find the center and the radius. Let me now talk through the steps now that we see the problems we're going to see. We need to collect the x and y's together. So all the x's, then all the y's. You need to move constants to the right side. If x squared or y squared has a number that's not 1 next to it, you got to pull that out, factor it out. You need to complete the square. That's what we just did. So I'll put a little star on it. The left-hand side, do the complete the square stuff. That's basically it. And then we need to divide sometimes to write the equation in standard form. Let's just do the example and you'll see that this is actually not so bad. So let's collect all the x's and y's together. So here I see I have some x stuff and some x stuff. I'm going to put those together, x squared minus 6x. And just for the sake of making it clear, I'm going to put it in brackets. All of my y stuff, I'm also going to put together. So plus y squared plus 8y. And then sort of what Zara said earlier, move the other number over. I'm sort of going backwards here. So let's throw that onto the other side. Why are we doing this, you might ask? The reason we're doing this is because this is general form. It is not the form of a circle. We're talking about a circle in this question. The form of a circle should look like this. Or more specifically, sorry, I should be more exact. The form of a circle, it should look like this. So we're trying to like transform or change the form into this shape, but it's going to be pretty easy. You'll see that. So what do I do now? If you get stuck, you can look back on the sort of cheat sheet here. We've collected them together. I moved constants to the right side. If x or y has a coefficient other than 1, factor it out. Does it? No, it doesn't. It doesn't have it, so I can skip that step. Oh, I need to complete the square. So take each one of those and complete the square. This is what it'll look like. X squared minus 6x. I'm going to add something to it. Y squared plus x 8y. I'm going to add something to that. And then I'm going to have 24 over here. So you tell me, what number am I going to put here? What's my mystery number? 9. Thank you, Zara. Divide 6 by 2, you get 3, and square it, 9. Right away, before I forget, I've got to add it to the other side. Okay, that one's done. What about the next one? What's 8 divided by 2? It's 4. 4 squared, 16. So 16 goes there, and 16 goes on this side. Now we need to simplify a little bit. We need to do one more step to factor this. What two numbers multiply to make 9 and add to make negative 6? Or in other words, what's negative 6 divided by 2? It's x minus 3, all squared. Plus y, I need to divide this by 2. So plus 4, square it. That 16 and the 9 disappear because I'm actually factoring it. I'll show you that in a second. And 24 plus 9 plus 16 is 49. Believe it or not, we're done now. This is the form that I wanted. This is, you can hopefully see that this is exactly that form. Well, this is why we need complete the square. This is why I talked about general form. And if you don't believe me that these two things are equal, well, I'll just quickly prove it to you. What two numbers multiply to make 9 and add to make 6? Sorry. Negative 3 and negative 3, which is the same as x minus 3 all squared. So that works every single time. Just in case you're not sure where that comes from, why it works, that's why it works. Am I done the question? I don't think so. I need to find the center and the radius of this circle now. So let's go ahead and do that. What's the center? Well, it's in standard form now, so it's really easy to take it. We just change the sign on the one next to x. Change the sign of the y one as well. And the radius, we just need to get the square root of 49. Because remember, this is r squared, so the radius must be root of that, which is 49. Sorry, 7. Okay, so just a reminder why we have what we have. It's from the section on circles that we did on Monday. Okay, how do we feel about that? Almost every example we do today is going to be similar to this. So if you got the basic idea, you will be pretty good with most of what we're doing today. Anybody? Going once, going twice. You okay out there? Everybody alive, or are you're just too tired to even interact today? I get it if you are. I understand. Okay, so let me see. I wanted to see what would be a good question to do. Yeah. Example 2 is a bit of a weird one. So before I let you do your own, I'm going to do it with you because there's a slight difference, and at the very end, something really weird happens. And I just want to mention it. Okay, so if you want to, you can go ahead and try this question, but right away you're going to find it's different. So let's just do one more together, and then we'll break it up. So find the center and the radius of the circle. So this is a circle, so we need to make it into a circle equation, a standard form of a circle. If you were to look at this and I didn't tell you it was a circle, hopefully you would still know that it was a circle. How would you know? Because I have x squared and I have y squared, and they both have the same number next to them, which is 1 in this case. So let's go ahead. I'm going to collect my x and y's. So I have x squared. Actually, sorry to waste your time here. This example is exactly the same as the previous example. So I'm not going to do it. I'm going to do B. Because, again, example 2A is literally the same as the first one. There's no difference except for some numbers. So I'm going to skip it for time. I'm going to do this one, though. Find all indicated points of interest for the ellipse. So it's ellipse given by this equation. So same idea I was just talking about. How do you know it's an ellipse? It has an x squared and it has a y squared, and there's two different numbers in front of them. And you can see that there's a plus in the middle, so it must be an ellipse. I can even tell you the shape, but we don't really care right now. So I'm going to collect my x and y's together. So that's all my x's, I'm sure you'll agree. And my y's, what are all my y's? 4y squared plus 16y. And the only thing left is that constant 16. It's a negative 16. That might seem weird to you to have a negative on that side, but the problem will work itself out. It'll be okay. That'll be taken care of as we go through this. So the first thing we had to do is collect the terms. Notice here that we have a 9 in front of the x squared and we have a 4 in front of the y squared. That's not a good thing. We have to factor it out. And by factor it out, I mean you take the 9 outside the brackets. So 9x squared divided by 9 is that. What's 18 divided by 9? Well, it's 2. So minus 2x. You're just factoring it out. If you multiplied it back, you would get the same thing as you started with. We don't want to do that. What do I do now? I factor out the 4. That leaves me with y squared. And what's 16 divided by 4? It's 4. So it leaves me with y squared, 4y squared. And again, if I multiplied this back through, I would get the same thing I started with. So I know that it's correct. Equals negative 16. I don't add anything to that side yet because I haven't completed the square yet. Hopefully you're with me so far. This is the step. Ooh, what did I just do? Oh my goodness, what have I done? I think I know what I did. Sorry. I moved my whole background. Oh, she's fixed. Computers, man. Weird. Okay, what am I going to do? I'm going to complete the square. X squared minus 2x. I'm going to leave a little space for y squared plus 4y. Leave a little space. And then I'll worry about what those numbers give me. Okay, so the first one, what's 2 divided by, looking at this, what's negative 2 divided by 2 and then squared? Negative 2 divided by 2 is 1. 1 squared is 1. Okay. What about this one? What's 4 divided by 2 squared? Plus 4. We already did that one. Now, what do I add to the right side? That's a trickier question. What do I add over here? What do I need to add here? Any ideas? I know you're not very talkative today, but I've got Kevin, Hamza, and Zada. Plus 1 and plus 4. So I knew you were going to say that. I kind of set a trap for you. I feel a little bit bad, but I mostly don't feel bad. Because, yeah, I wanted you to fall into the trap so you will remember this. The problem is, this 1 is not actually what we added. We added 9 of them. I haven't seen you, I don't, in a long time. Yeah, it's 9. Take this 9 multiplied by 1, and then that's what we need to add, because that's really what we're adding here. Okay, so they need to multiply. Hey, Mohammed. The other step here, this 4 times 4 is really what it gives us. What's 4 times 4? 16. So really I'm adding 16 to the left side. So I need to be adding 16 to the right side as well. So if you're going to remember anything on this, this would be a really good place to remember. Don't mess that up. You can't solve the question without it. You knew that. Yeah, okay. I won't pretend that I believe you. So let's continue to complete the square. This is x minus 1, because I take this number divided by 2 and just write it down. For the square, 4 y plus 2, all squared, equals, what's negative 16 plus 9 plus 16? It should give 9 if my question worked out properly. I mean, if I did the calculation properly in my head. Oh, of course it's 9. These cancel each other. That should have been easy. All right, what do I do now? Well, this is supposed to be an ellipse. And if it's supposed to be an ellipse, there needs to be a 1 on the right side. And if I don't have a 1 on the right side, I need to force it to be a 1 on the right side. So what I do is I divide everything by this. So divide the left side and the right side by 9. Divide everything by that 9. And this is what's going to happen. It'll cancel the first one, leaving us with x minus 1 squared all over 1. You don't need to write the 1. You could ignore it. And this is a weird one. Just take my word for it for now, because this, for some reason, this works out really strangely. It's the only time it happens in the entire course, so I'm actually not going to even talk about how I got that. You would need to divide it, and if it doesn't work out nicely, you actually need to flip the fraction. But just take my word on it for now. You won't see that again. That's just a bit of a special case, and don't worry too much about it. Just trust me for now. I've divided everything by 9. Normally, it's like it works out to a nicer number. Okay, so that's how we do these questions. That's how we force our general form into standard form. Now, there's a little bit of a problem. And the problem is, it asks me to find all indicated points of interest. Do you know what that means? It means it wants the center. It means it wants the vertices. It means it wants the co-vertices. It means it wants the foci. And it wants the eccentricity. There is no chance that I'm going to do all of those in this question. I don't care what's in this book. That is a way too long a question for a test or an assignment or anything like that. So you can look at the solutions, because I'm going to post full solutions for it. But once we get to this point here, we've already done that many, many times. So basically, if I was going to ask you to do this, I would give you this, and we would just work from that. Okay? So even though it asks for all those things, I'm not going to do it today. You can use it for extra practice if you want, because of course, let me be clear on this, I will absolutely expect you to know how to do that for a test. In fact, I'm going to expect you to know how to do that for the assignment too, for this and for hyperbolas. But I'm not going to expect you to change the form and do it. Okay? Hopefully that's clear. So I'm going to do another question. I'm going to skip C and D because they were done in the video by Tom, just like this one was. And we'll just keep practicing. Okay, we'll just keep practicing. So example 2. I don't think Tom fully did this. So I'll start it for you. This one's really short, so I'll do this one for you, then I'll have you do B. Let's just take a look. Can someone tell me right away what form this is? Like, what kind of conic is it? It says identify the following conics. So what is the conic, or the conic section? What kind of form is this? What is it? Anyone know? Let me just show you. Should I show you? Well, it's not obvious because it's in a weird form. Circle, you're right. You're right. And some students can pick it out from the very first step. Other students see it pretty clearly from the second step here. But yeah, you should definitely see that both of these are squared and they have the same number. So right away, we should be able to see that it's a circle, okay? So I'm gonna write over here, like my guess is that it's a circle. I'm going to force it into standard form and then it'll confirm if it's a circle or not. So in order to get this into standard form, I divide this by 2. Because remember, a circle needs to have just 1s in front of the x and y squareds. So that gives me x squared plus y squared. What's 8 divided by 2? 4. So I'm dividing everything by 2, okay? Take everything, divide it by 2, and we get our final answer. And then that's definitely a circle. I could ask you what the center and the radius are now if I wanted to, and you should be able to get it. This is a circle. No question. That's a circle. As an extension, which I mean, it's not asked in this question, but just something that I could ask you if I wanted to in a different way. Tell me what the center is. Okay, in this case, the center is 0, 0. Tell me what the radius is. And in this case, the radius is 2. All right, that would be sort of extra things that you would need to normally know about the circle. For example, I would give you this, and you have to give me back that. You see what I mean? Okay. It's not a must to do it right. Oh, no, for this question, you don't need that. I'm just adding it as an extension so you remember how you get that. But it is not, I did not ask it for this question. It's just a review of how you would get that. Okay? It would be 2 separate questions. Okay, so try B. It should only take you maybe 2 minutes to get this into standard form. Give it a shot. See how far you can get it. I'll come back at 4:47. Okay, it's 4:47. Figured that would be enough time to get the main things. And what I did was this. Should be able to see this. Hamza, you have the same answer as me. Okay. So I'll just resume. This is what I ended up getting. I'll use my fancy replay, which is just very helpful. And I'll just talk through my answer, just in case not everyone got that. So the first thing I did was I collected x and y terms. You can see that x terms are collected and y is collected. I'm going to factor out 3. That gives me this, and I'm leaving space for the completing the square, and I get this. So once I get to this step, I need to figure out, all right, what is -2 divided by 2 squared? Or how do I complete that square? Well, I get a 1, but on the other side, I need to add 3 because, I wonder if I can draw on this. 3 times this gives this. Okay. I don't know how that, okay, I might have broken the mainframe here. There's a glitch in the matrix. So that's okay. That's that step. And then you can pick through my workings here. I probably should have just done it with you, but I thought it was going to be fancy. So -2 divided by 2 is this. Put the square on the outside. Everything else is okay. Make sure you divide everything by 6 at the end. You know, you have a 6 here, which it needs to be in the ellipse form, which is equal to 1. Divide everything by 6 to get it equal to 1. And now we have an ellipse. So hopefully it's clear what the answer is. Again, I'll talk through the rest. I regret doing what I just did. As an extension, and I'm giving the extension not because this would be a full question in itself, but because the question that would normally be asked would start here. And in order to answer the question, I would want center, vertices, co-vertices, foci, and eccentricity. So I'm going to write those out. I'm going to start it as if I had been given this from the beginning as a review of how to do ellipses. Okay, so let's get started. Center. The center, you would look at this, again, I'm looking at the bottom left here, would be 1 and 0. That should be very simple. You should know how to do it. You have to know how to do it. To get the vertices, you pick out a squared. Which one of these is a squared? Is it this or is it this? 6. Good job, Zara. It is not the first one because this is not hyperbolas. This is the biggest one, 6. That means a squared is √6. I won't bother simplifying that. In order to get the b squared, it's the other value, which in this case is 2. So b squared is 2. That means that b is √2. And then if I was to get c, or c squared, it's a squared minus b squared for ellipses. That means that it's 6 minus 2, the square root of that, which is 2. Again, doing this quickly because we've seen it all before. I just wanted to review it so you see it again. How do we get the vertices? Well, I'm going to have to draw a quick sketch here because I do better thinking about this as a sketch. 1 and 0. So my circle will be, my center will be here. My major axis is the y-axis because it has the bigger value on bottom. So it's stretched vertically. That's all I really needed. I know it's going to look like that. It's not asking me to make an accurate sketch, so I'm not going to bother. You should be able to do it. So what are the vertices? I'm going to run out of space maybe. Maybe not. Vertices? I'll use V, sorry, just to save space. V, the vertex must be up and down. So we need to take the center and add 6 up, or √6 up, and come down by √6. So it's going to be 1 and √6, 1 and -√6. If you don't know how to do that, you haven't done enough practice. Co-vertices. So take the center, which is at 1, 0, go left and right by 2, by √2. So it's 1 minus √2, 0. 1 plus √2, and 0. I'm just getting things like these points here. The foci. You take the center, you go along the major axis, up by 2, down by 2. So this is 1 and 2, 1 and -2. And the eccentricity I'll write to the side. C over A. So it's 2 over √6. which is root 6 over 3 if you simplify it. Okay, so I just want to be clear. I would never, ever, 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 ever ask you to do all of this in one question. I would never have you do the form at the start and then get all your 5 pieces after that. It would be crazy because what if you make a mistake at the beginning? It wouldn't make any sense. What I absolutely would and probably will ask you to do is to get these 5 pieces from an equation that I gave you. We've done many of those. That shouldn't be a surprise. Or take an equation in general form and make it in standard form. 2 different questions. So that was what Hamza asked me earlier. Would I be expected to do this? Not for this one big question, but you of course need to know how to do all these pieces. Okay, any questions on that before I do many more examples? Anybody? No. Okay, let's do it again. The next one. I look at this and I see an x squared and the y squared. So it's either an ellipse or a hyperbola. And I see a minus in between them. So really what really matters is this minus. It's a hyperbola. So even before I start, I know that that's what I'm going for. My answer will confirm that. My answer will tell me that that's true. But for now, yeah, I guess we're missing Yasser today. I need someone to give me a math. Okay. Hyperbola. Let's do it. Group the x's together. Okay, now they're grouped. Minus y squared equals negative 14. The negative is not a problem, just like it wasn't a problem last time. It'll work itself out. Factor the 2 outside. You get this. I'm going to leave space to complete the square. And I get this guy. I get this. Complete the square. Someone tell me what that number is. I'll make sure you're all awake, and I'll make sure we're always doing this together, at least to some extent. Divide the 6 by 2 and square it. You get a 9. Good, thank you. Ibrahim and Kevin, excellent, thank you. 2 times 9 equals 18. On the left side, that's x plus 3, because I just divide this x by 2, minus y squared equals 4. Okay, the right side is fixed. And the only thing left is that we need to take that 4, divide everything by that to get it equal to 1. So what's 2 divided by 4? Your calculator should give you 1 over 2. That's a good hint. You know, x plus 3 squared over 2, just like the calculator gives you. Minus y squared over 4, because you're dividing everything by 4. We're done. And in the beginning, I said it was going to be a hyperbola. Now it's confirmed that's definitely a hyperbola. Good morning, Esther. Good morning indeed. What does time even mean anymore? You know, some of you, I'm sure, are sleeping in the middle of the day between classes and all sorts of stuff. I get it. I've had a few students that tell me, sir, I have class. I go to bed. I wake up for my second class. I go to sleep again. I wake up. I do practice. Everything's backwards. We're like night people now. My parents thought I was drugged. I hope not. That'd be bad. But it's nice to see you here, even if you are almost an hour and a half late. I'm glad that you made it. Okay, so once again, I'll do the extension just to do as a review. Extension. By extension, I mean I need 5 things. Now for the hyperbola, the 5 things are center, vertices, co-vertices, foci, and we don't have the eccentricity this time, we have asymptotes. So I'll just go ahead and do that. How do we get the center? Let's see, the center is 3 and 0. Negative 3 and 0. Negative 3 and 0. That would have been bad. Everything is based off the center. You set the alarm to AM instead of PM. Well, we're not all perfect, are we? It's okay. I'm just glad you're here. A squared. What's a squared? I'm counting on Zara for this one. He usually jumps in on this. Oh, Kevin beat you to it. So a squared is 2. A squared is the first one for hyperbolas. It is not the biggest one. Okay? You got to get that in your head. Hyperbola's first one is A. Ellipse's biggest one is A. Talking about the denominator. So A is root 2. Let's get B. B squared is now 4. So B must be 2. C. Well, C squared is the same as Pythagoras for hyperbolas, A squared plus B squared. Plus, not minus. That means that C is, what's 2 plus 4, square root of 2 plus 4, so root 6 again. Okay, just a coincidence. Wait, is that right? Yeah, okay, sorry, I think I was thinking about the previous question, root 6, and it threw me off. So I got root 6 again. I'm gonna draw a quick sketch. You don't need to, it doesn't ask to, but again, I'm much better at this if I draw the sketch. So this is an X first type. It's gonna look like this. The center is gonna be right in the middle. I'm gonna have vertices on either side. I'm gonna have foci to the sides of that. So the center here is -3 and 0. Now I know clearly most of my action is happening left and right, not up and down. So my vertices, my first vertex, I take the center and I go left and right by root 2. So the center, that'll be -3 minus root 2 and 0. -3 plus root 2 and 0. That's a weird one, but that's not unusual to see stuff like that. My co-vertices, I go up and down from the center by 2. So that's -3 and 2, -3 and -2. Again, if you haven't seen this, if you haven't practiced it, if you haven't been coming to class, if you haven't been watching the videos, you probably don't have any idea what I'm doing now. Even if you have been on all the classes, maybe you're still not completely certain. So make sure you get all the practice in that you can, as much as humanly possible. The focus, take the center, and the distance from the center to the focus is C. So go left and right from the center by C. So -3 minus root 6, 0. -3 plus root 6, and 0. And the only thing left to do is the asymptotes. How do I get the asymptote? Does anyone remember? Remember how I got this yesterday? I'll write down I'll remind you what the general form looks like. It looks like this. And it's something over something. That something is the y-related value divided by the b-related value, but the square root of them. In other words, b, in this case, b over a. If you were to draw that, it would be the rise over 1. Okay, so what's my asymptotes? Can anyone hazard a guess? I'm surprised Hamza isn't jumping over himself to get into this one. Y equals plus or minus something x plus 3. Well, the b goes on top because that's the y-related one. It's okay. This is root 2, and I'll keep it like that. Kevin, did you mean to raise your hand, or was that a mistake? It was probably a mistake. Just tapping around things. It's all good. So our asymptotes are that. So that's our final answer. Now again, I want to be clear. I want to be clear. I would not ask you to do this whole question on a test. I would either ask you the left part of the question or the right part, which means I would give you the equation and ask you for those 5 pieces. Okay? I wouldn't combine them. It would be crazy. It would be just a nightmare for me and for you. Okay? But you need to know how to do every single piece of this. This is the easiest version. Like, that's the minimum that I'll ask, is to get those vertices, co-vertices, and things. Or maybe I'll just ask, okay, give me the center and the vertices. or give me the center and the covertices only, something like that. But you need to know how all these things work. You're not going to know what I'm going to ask you, right? There's no sample tests or assignments. Okay, let's continue. Let's continue. So D is a special case. I'll just go ahead and do it for you. You don't really need to worry about it too much. XY equals 36. If you remember from a couple days ago, if you have something in this form, XY equals a constant, it's a hyperbola. This would be kind of like a bonus question sort of thing. We didn't really cover that very much, so I'm not going to cover it very much now. But just to prove it to you, XY equals 36, so I'll write it here, I guess. XY equals 36. My tiny keyboard. XY equals 36. It looks like this. And don't forget, you can always write this in undesmos, okay? So it looks like this. You can always take your graphs, you can always take your equations and type them into Desmos. It will show you if it's a circle or an ellipse or a hyperbola or a parabola. I'm just giving you skills that you can figure it out without having to graph it. It's faster in a lot of cases if you actually understand it. But don't be afraid to graph it. There's no reason why you can't. It will tell you a lot of information that you're looking for, okay? And then you can check your answers with it. All right, I want to do E. E is actually, you know, one of the standard questions, one of a more normal question compared to the last one. I'll do the first set for you. It looks like this. And then I want you to get the equation for me. Actually, we haven't done one like this. So I don't want you to do it yourself because I'm afraid you're going to get stuck. But let's talk about it. What kind of, oh, you solved it. You got the parabola? Some sort of wizard? What'd you get? What's your final answer? I'm curious now. Put you on the spot. I'll do this in a second, but I'm really curious. Okay, I'm tired of waiting. This is a parabola. How do I know it's a parabola? Because I see, yeah, that's right. It's perfect. Great job. I know it's a parabola because I see a single y squared and the other x in there is not squared. So it's got to be a parabola. It's going to be y squared form. So it's going to open up or down. I think in this case it's going to open to the right because I can see that this constant here is positive. But I'm going to pretend I didn't know that. Let's move ahead. So on the left side, I need to collect all my y's. It looks like this. On the right side, I'm going to collect my x's. That's different. How did I possibly know that? Well, you need to see that it looks like a parabola, and then you know what the parabola is supposed to look like. The equation for a parabola is supposed to be like this. So we need to make it look like that, which basically if you just put all your put all your squared stuff to the left, whatever letter that is, so get all my y stuff to the left, and keep all my x things to the right, it'll work most of itself out according to the plan that we used before. We're going to factor the 4 out. 24 divided by 4 is 6. Divide that by 2 and square it. I'll do that after, actually. On the right side, 16x plus 28, and then I'll go back and write those in. 36. Okay, so I'm not going to talk through these steps. I've already talked through this enough. I want to talk through the later steps. Okay, now we should discuss it. In this case, we have a different situation than we had before. The problem is, in our general formula here, our standard form, there's no number in front of this bracket. So look, there's no number here. Now in this case, it's a 4. I need to make it a 1. I need to get rid of it. I need to divide everything by 4 in order to get rid of it. Okay, so I'm going to divide everything by 4. Divide everything by 4. What does that do? It gives me y minus 3 on the left squared. That matches the form that I want. Look, this now matches this form perfectly. So I'm on the right track. On the right side, what's 16 divided by 4? It's 4. 64 divided by 4 is 16. That is so close to the right. I just need to factor now, and I'll be done. So the left side is fine. The right side, I just need to factor that 4 outside. And we are finished that question. All right, that's done now. It's a parabola, but we already knew that. There are different ways to solve this. If you just sit down and actually try to practice them, you might find your own ways that make the more sense to you. But this is the basic idea. So Hamza, did you basically do the same steps that I did? Okay. And similar is a good word. If it was similar, that's enough. You don't need to do the exact same thing, but something like it. Just before I forget, you should all know that in content now, in the D2L shell, I have the full solutions. So the notes are there blank, and just the final answer is there. My handwritten solutions are there, and the full solutions, like step by step by step by step for every single question in the book is there. So no excuse not to be able to do practice problems. It's all there for you. It's just a matter of how much motivation you have. So let me do the extension, just in case I was to ask something like this on the test. Again, the extension is like I would start with the formula and then work it out. So what would I care about? I would care about the vertex, not the center. Parabolas don't have centers. What's the vertex? Well, the vertex, I steal the x and the y stuff. Minus 4 and 3. What else do I need? I need to make a sketch. I find it very difficult to remember how to do this without a sketch. So minus 4 and 3. I don't need anything more than this. I can just say it opens to the right. My vertex is here. Minus 4 and 3. My focus will be inside. And there's a directrix. You remember about the directrix? Does anyone remember back to Sunday? The directrix is on the other side. What's the distance from the center to the directrix? It's P, right? And to the focus. So these are important concepts. You need to remember those, okay? Hint, hint. I'll just tell you directly. There's a question on your assignment that I'm not asking you to give me just the 4 pieces. I'm asking, I'll give you the vertex and either the directrix or the focus, and you need to give me back the equation. All right, big hint, big hint. We've done questions like that before. You just need to look back in the notes. Okay, so how do we get P? Well, I know 4P is this 4. So I know that 4P is the number in front of the brackets here, 4. That means that P is 1. Okay. That's useful information. What does that give us? That gives us the focus. Maybe I'll make it yellow just so you know they're connected. That means the focus, and there's only one focus for parabolas. What is it? Someone tell me the coordinates so I know you're still alive. Coordinates of the focus. I need to take the center and go over by P. Go over P units. So I'll go to the right by 1. If the center is at negative 4 and 3, going right by 1 would be negative 3 and 3. Okay, so this is Sunday's stuff, but we need to know how to do it. Directrix is my last thing I'll be asked. Directrix, what's the directrix? It's an equation, it's this line here. You go 1 unit to the left from the vertex. So that would be x equals negative 5. So what I would care about is this, this, and this. I highly, highly, highly recommend you always make a sketch. If you don't make a sketch, you're making it much more difficult on yourself, okay? That's all I can really say right now. So again, I want to be clear, very clear. You would never get this entire question as once. You would have it in 2 pieces, okay? Anything I can go through there? Is everyone as tired as I feel? Yeah, I'm hungry too. I've been lucky. These classes, they go late, so I go downstairs and my wife has made supper. It's like awesome. Or I see the Taliban driver driving up. I'm like, cool, what's for supper tonight? Can we end the class now? Well, yes, we can. We'll stop here. What I will say is that the other class, my section 3, I managed to cover a little bit more material. That video has practice 1 completely done, okay? So I'll post the solutions for this online, practice 1, my solutions. But if you want the worked solutions with my voice on top, just watch the video for class, section 3 class on YouTube. Okay? I'm just gonna stop the recording and then I'll answer some questions. Okay, bye-bye, everybody.